Now we're going to calculate the angle of intersection between two planes. One is the angle between the plane x plus y plus c equals 1 and x minus 2y plus 3c equals 1. And the other is the angle between the planes 3x minus 6y minus 2k equals 15 or whatever. Could be whatever number we are going to see y. And 2x plus y minus 2c equals 5. If you think you can do it, stop the video now and next continue to see if we have the same result. Alright, first, so we have the plane x plus y plus c equals 1 and x minus 2y plus 3c equals 1. Let's say that I have this plane and this plane. Alright, and I want to know the angle of intersection. This is the same angle as the angle that their respective normal vectors produce. This is, let's say we have this plane. It's a little bit difficult to draw it. And another plane, let's say this plane, and well, it's very difficult to visualize it, but we want to know the angle. This angle is, this vector has this normal vector, and this angle has, let's say, this normal vector, so this normal vector. So the angle at which these planes intersect is the same angle at which these vectors, or is the same angle at which this vector intersects or has. I think that it was more clear with my hands than with this. Anyway, alright, so we need to, from the equation of these planes, we need to calculate the equation of, or the vector, the normal vectors for each plane. So the normal vector for this plane will be, let's say v1 equals 1 or I plus j plus k, and this v2 is I minus 2j plus 3k. This is, as I said, because I forgot to put this number, it doesn't matter, it's the same intersection, let's say, between this plane and this plane, and this plane and a plane that here says 1000, whatever. It doesn't matter if I change these numbers, because as in the video in which we derivate the equation of the plane, it doesn't matter which number we put here. The x plus g plus c equals d is a family of planes that are parallel. So I have x plus y plus c equals 1, x plus y plus c equals 15, whatever, and I have this angle that intersects here. So the angle at intersection between this and this plane is the same angle of intersection between this plane and another plane that is parallel to the first plane, or this and another plane parallel and this another plane parallel is the same angle. So it doesn't matter which numbers we have in the right side of the equal sign. Alright, now we have these normal vectors. Now let's calculate the angle. We know that v1 dot v2 is equal to the magnitude of v1 times the magnitude of v2 times the cosine of the angle. So the cosine of the angle, because we want to know the angle, so first the cosine of the angle is equal to v1 dot v2 divided by the magnitude of v1 times the magnitude of v2. So let's calculate first the magnitude. Here the magnitude is root of 1 square plus 1 square plus 1 square is just root of 3. It's equal to the magnitude of v1, and the magnitude of v2 is 1 plus 4 plus 9 is root of 14. Dotting, we have 1 times 1, or I dot I 1 plus j dot minus 2j is minus 2, because remember that the angle between j and k, I and I, k and k is 0, so when we multiply the magnitude of j times the magnitude of j times the cosine is just j squared, that is just 1, and then times this constant, or whatever way you want to visualize it. 1 minus 2 and plus 3 divided by root of 3 times root of 14. This is 4 divided by root of 3 times 14 is 42. So we have the cosine of theta is equal to 4 divided by root of 42. We have theta is equal to the arc cosine of 4 root over the root of 42. I already saw this, and this is approximately 72 degrees. So we know that the angle between the normal vectors for each of one of these planes, that is 1, 1, 1, 1, and 1 minus 2, minus 3. Oh, these vectors, the intersection, the angle of intersection is 72 degrees. So the angle of intersection between these two planes is 72 degrees. Now let's do the other example. Now we have these planes, so let's calculate its normal vector. So we have their normal vectors. We have v1 now is 3i minus 6j minus 2k, and sorry, here was c, sorry, and v2 is 2i plus j minus 2k. Alright, now dotting them would be 6 minus 6 plus 4 divided by magnitude of v1 is 9 plus 36 plus 4 is root of 49, it is 7, and v2 is 4 plus 1 plus 4 is 8, 9 is 3. So divided by 7 times 3 is 21. So it is 4 divided by 21. So we have theta is equal to the arc cosine, or you can say cosine minus 1 of 4 over 21.